When testing the graph of an equation for symmetry, there are three ways that it can be symmetric. And those ways are x-axis symmetry, y-axis symmetry, and origin symmetry. And each has their own way to test for it. To test for x-axis symmetry, you're going to place y with negative y in the equation and simplify. If an equivalent equation results, meaning the same equation results, the graph of the equation is symmetric with respect to the x-axis. For y-axis symmetry, you're going to place x with negative x in the equation and simplify. Again, if an equivalent equation results, the same equation results, the graph of the equation is symmetric with respect to the y-axis. And for origin symmetry, you're going to place x with negative x and y with negative y in the equation and simplify. Just as before, if an equivalent equation results, meaning the original equation, the graph of the equation is symmetric with respect to the origin. And you can have multiple symmetries, not just one, or you can even have none. So let's look at a few. So we're going to test each equation for symmetry. So y squared equals x plus 4. So to test for x-axis symmetry, we're going to replace y with negative y. So for x-axis, y squared is going to become negative y squared equals x plus 4. And so negative y times negative y, that's equivalently going to just be a positive y. So positive y squared equals x plus 4. And now that we've worked it out, is this equation equivalent to the original? In this case, it is. So we can say that this equation has x-axis symmetry. Now let's try with the y-axis. We're going to replace x with negative x. So y squared equals negative x plus 4. Can't really do anything with negative x, so y squared equals negative x plus 4, just to write it out. And is this the same as the original? And that answer is no. So there is no y-axis symmetry. And last, we're going to test for the origin. We're going to place x and y with negative. So negative y squared equals negative x plus 4. Again, this becomes positive y squared. This stays a negative x, and this becomes a 4. No change. Now, is this the same as the original? That answer is no. So the only symmetry for this equation is x-axis symmetry. Now we're going to do again with x squared plus y minus 9 equals 0. So we're going to start off with x-axis again. Xi, x-axis. So replace y with a negative. So x squared plus negative y minus 9 equals 0. Work this out. X squared minus y minus 9 equals 0. And is this the same as the original? And the answer is no, it is not. Now we're on to y-axis. Replace x with a negative. So negative x squared plus y minus 9 equals 0. And negative x squared is going to give me a positive x squared. Everything else stays the same. And then I look and see, is this the same as the original? And it is. So this equation has y-axis symmetry. And now I'm going to do symmetric about the origin. Replace all my x's and y's with negatives now. So negative x squared plus negative y minus 9 equals 0. And this is going to give me a positive x squared. This will stay a negative y. And this will stay negative 9. And is this the same as the original? It is not. So the only symmetry for this equation is y-axis symmetry. Y equals cube root of x. Let's start all over again. So x-axis means replace y with negative. So negative y equals the cube root of x. And negative y is just going to be negative y, cube root of x. So is this the same as the original? It is not. So it's not x-axis symmetric. Now I'm going to do the y-axis. Replace my x with a negative x. So y equals the cube root of negative x. And the cube root of a negative number can be equivalently written as negative cube root of x. And is this the same as the original? Nope. Not that one either. Now we're on to origin. That means x and y get changed. So negative y equals the cube root of negative x. And this would just be a negative y. And again, just like before, I could take the negative out. So it's negative cube root of x. And I can actually see that I have a negative on both sides here. So I could just multiply a negative across or divide the negative across, whichever I prefer. And I'm going to get y equals the cube root of x. And here, this is the same as the original. So this only has symmetry with respect to the origin. Next, we have 9x squared plus 4y squared equals 36. And so x-axis first. I'm going to replace my y with a negative, so 9x squared plus 4 times negative y squared equals 36. Which way I work that out? I'm going to get 9x squared plus 4y squared equals 36. And this is the same as the original. So it has symmetry with respect to the x-axis. Now it's time for the y-axis. Replace x with a negative. So 9 negative x squared plus 4y squared equals 36. And that's just going to simplify down to 9x squared plus 4y squared equals 36. This is again the same as the original, so symmetry with the y-axis. And I'm sure you can see where this is going for the origin. If all of them change back to normal, this one is going to as well, which, as you can see, it does just as expected. So again, since this is the same as the original, it also has symmetry with respect to the origin. So this actually has symmetry with respect to all three, x, y, and origin. And now finally, y equals y equals x cubed minus 27. So x-axis, replace my y with a negative. And negative y is not going to do anything, so it's just y equals x cubed. Sorry, negative, missed that there. And now I have this. Is this the same as the original? It is not. I'm going to go on to y now. Test this by replacing my x with a negative. So y equals negative x cubed minus 27. Negative x cubed is equivalently written as negative x cubed minus 27. And is this the same as the original? Again, this is not, so not symmetric here. And finally, last one, origin. Negative y equals negative x cubed minus 27. Well, I can take the negative on both of them, like so. Negative y equals negative x cubed minus 27. And I can try again with the origin. I can multiply or divide everything by -1. And when I do that, the y becomes positive, the x becomes positive, heck, even 27 becomes positive. So is this the same as the original? And because of that 27 becoming positive, it is not. So this actually has no symmetry with respect to the x-axis, y-axis, or the origin.